coming back. I'm coming back. All right, I'm back. I'm back. So I'm not sure what you mean about questionable practice. If you can clarify, I can maybe explain better. There are 3 toStrings, one from standard, one from student, one from class. Yeah, you're absolutely right. That's the difference. In fact, there's kind of like over here, we called a toString in the student, which I don't know why that disappeared. Oh. My computer is certainly having a hard day. There's actually kind of like a 4th toString, because this standard library's toString student number was an integer, but current average was a double. So it called the one for the integer and then the one for the double because, well, its type was that. Here we've got the standard library that's just going to convert the student number of students, which is an integer, and then we're calling the toString from the student class. So it's this toString. And the reason we like to have them all have the same name is because if you're a programmer and you call, if programmers are following the proper conventions, and this, remember, C++ is a little funny, so there's a couple of asterisks that should go along with what I'm saying. But if you're a programmer and you get some code written from someone else, maybe a class written from some other programmer, if that other programmer was following the proper conventions, which they absolutely should be, I know that I can tell whatever object it is, that object is going to have a function called toString. And if I tell an instance of that object to do its toString, it's going to go call the toString that's defined for that object. And every object will have a slightly different toString depending on what you want. In our case, I wrote it in such a way that it's just going to be student number followed by lines defining whatever the students are. So with this here, I'm going to also, let's do like a new line or something. Oops. And then I'm going to call this again down here right after I add all these things. So we can see how the toString looks at the beginning, which, I mean, it'll be empty. Then we'll call it again after we've added the 5 individuals. So let's build. So the first thing we did was print out the string of the student. So because this is a student and I called toString, it calls, okay, the student's toString. John Doe, student number 0, that's their email, tab, they've got 100%. Then we called C toString, and C, well, what's its type? Well, it's a pointer to a student, or pointer to a class, a course, and then we dereference it and get the toString. So this is going to call the toString written and defined for the course object. And right now, well, that's just number of students. Well, that's just, okay, 0 because there's no one there. Then I guess I add a new line and then another line. All right, so we get a new line, another new line. Then down here, we're adding all these things, and then we're asking the course to stringify itself again, print it out. Well, number of students, 5. Then we've got James Hughes, Bob Smith, Sally McDonald, Greg Roots, and Sarah Davidson. The 5 of them, great. So in this case, the toString, this is the toString for the course object, and then this is the toString for the student object. But the course's toString actually makes use of the student's toString. I could have written this out to say, okay, get that individual student's email address, whatever, basically replaced this with all this code, right? Because this right here returns, like this right here is effectively calling that function, that method, that's this. So I could replace that with all this, right? But why do that? I already have a function called toString because that's convention. We all know that each object, if they're following the convention and they have the method toString, I can call it regardless of the class. And I can take the string version of whatever object that is and then use it for this one's toString. Now imagine we had a super or a bigger class, like a class that was like university, okay? And it stored an array of a bunch of courses. I mean, that makes sense, right? If I were to make the toString for the university, well, I would probably call the toStrings for the individual courses that belong in the array for the university, which in turn call the toStrings for the students. So it's this beautiful propagation of kind of like, look, I don't know how to stringify the student. I don't know. I have no idea. I don't care though, because the student knows how it should be stringified because the programmer for the student class wrote that, and it's called toString. I think there was another question in here. Okay, when we go object toString, it picks the right one for the object. Well, it's not even that it's picking the right one though. It's remember, it's not going, oh, they're calling toString here. It's not that it's going, oh, they're calling toString. I better go somewhere in RAM and make sure I understand which, oh, it's the one that belongs to student. It kind of goes the other way. It's like, okay, from this instance of a student, so we go to that student object in RAM, and then that student object in RAM knows that, oh, well, this toString, well, that's this code right here. This code is represented, where the heck is it? This code is represented in RAM somewhere. So it runs this code because this is what belongs to that. So it's not that we're going toString and, oh, I better pick the right one. No, it's we've got this and we're using the one function from defined for this object called toString. That nuance might not, like, it's really not that important for getting your code working and everything, but it is an interesting difference. Is using toString the same concept as using, yes, effectively yes, but if we were using a more modern language like Python or Java, then the toString is better universally used. It is the repr in Python, it is. But in C++, the toStrings, because there's the standard libraries toStrings and they don't have this nice clean way of enforcing certain things, it becomes a bit of a nightmare because again, C++ has the disadvantage, pardon me, let me reword it. Java and Python have the advantage at looking at what worked really well with C++, but also identifying like what didn't, and then they improved upon it because C++ is way old compared to the other languages. So that's why the toString in C++ is kind of ugly, where in Java, it would, like, in Java, everything's called toString. In Java, repr is just toString, that's it. And you can always ask anything what its string version is. So let's not worry too much about this toString though. Okay, great. Now let's test so far. Okay, well, we just did that. Oh, yes, actually, let's do this test. See the difference? So if we go, I'm gonna get rid of these actually. So what I'm doing is I'm adding the 5, but remember the course only has size 5, right? So if everything's working properly, I should see the course written out with the 5 students, and then I add another person called Andrew Roy, who needs to get their act together, and then we should print it out again. And it should work just fine. It should work such that it has 6 students and Andrew Roy's there just fine. Like there's no issue. So let's see, let's make sure this works because it should. If not, we've got a problem with our code. Looks good. So we've got number of students 5, James Hughes, Bob Smith, blah, 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 ends with Sarah Davidson. And then here we go number of students, well, 6, because we added that 6th person and we've got Andrew Roy there. And in this particular example, because with expand capacity, we always double the size, this particular object's max would be like, what was it called? Array max would be 10 now because it got doubled in expand capacity. And what's this worried about? Using uninitiated memory C. What? No. I don't know what it's upset about, but whatever. So great, cool. Now remove. If we want to remove something, oh wait, actually before I go on to this, I want to perhaps clarify what I mean about the add. So if I go here, here's my add. I could take this code, in fact, here's what I'm gonna do. I'm going to take add and create another function called add, but instead I'm going to have it take a student pointer. There. So I've now overloaded this function. This function add has two versions, one that takes all the information to create a student object, and then one that takes a pointer to an already existing student object, meaning that we kind of eliminate the one step. So let's see, I'm going to do this. Where am I? I'm all over the place. We're going to take this, copy, paste, and then this is going to be, what was it called? Oh my goodness, what did I do? My poor computer today is really struggling. I'm super lazy, so I'm going to do this. Okay, and if I do this, I can just, you know what, I'm going to call this toAdd actually, because then I have to change even less. Whoops. There. Now here, I can just, this is basically the same, but I can just do this. And now look, I have a version that will take the information to create the student, or if you happen to have a student already existing, well, here it is, just go ahead and add it. Something else we could do is, if we want to get super fancy, I can take this out and then just call add and give it to add. Look at this. I can't remember what this is called. Chaining, I think? Forgive me, I don't remember right now, but I think this is called chaining, like the functions. So this function, add, which takes, and I do want to note, now I'm just getting fancy. I'm just kind of like showing off fancy ideas. This one here takes the information to create a student. This one here expects to have a pointer to an already existing student. But you'll see that originally, all this code here, like it was there, but that's redundant. Like the code is written here and the code is written here exactly the same way twice. So we've got like some redundancy, which some people might say like, we don't like that. We don't like redundancy. So what I'll do is this add will call the add that takes a pointer to a student. So it just kind of is like, okay, I've created it. Now I'm going to hand the one that I created to this one that just takes the pointer to the student. If that makes sense and you're like, oh, neat, fantastic. If that terrified you a little bit, don't think too much about it then, because it doesn't matter at this stage at all. But hopefully if you thought it was neat, cool. So remove. How are we going to remove? Well, I suppose, and okay, I'm going to be clear. The way I'm going to write this right now is a perhaps particularly verbose way. And the reason it's particularly verbose is because it's effectively me showing off the use of our equals function. So what I'll do is I'll create a dummy student object. And you'll notice that this is, it's not a pointer. So I'm creating a dummy student object that has the student number of the student we want to eliminate, because we're also assuming that student numbers are unique among the students in the class. Then I'm going to do a linear search through my array. Simple. I mean, we've seen the linear search a billion times already. Maybe not quite that many times. And we're going to say, okay, is the student that's pointed to by the thing at index I equals to dummy? If it is, delete my class at location I. Then what do we do? We're currently in the situation, imagine we've got this as our array. And we've got, okay, a pointer, a pointer, a pointer, a pointer. Okay? A human, or pardon me, a student, and a student. And then we come along and we want to say, okay, no, we're actually deleting this one right here. Okay? So we delete what my class at I looks at. And I guess in this case, I was 1. Now I've got this like empty spot, right? I've got a student followed by a pointer that gets us to nowhere, which is problematic. And then at index 2, we've got a student, So we've got this gap. how are we going to address this? Well, since we've got two options here, actually. We could shuffle everybody down one, right? Which isn't too bad. But then again, imagine I had an array of size, I don't know, 1 billion. I guess 1,000,000,001 because we start counting at 0. So this is a huge array. And if I come along and I just so happen want to delete this one, I'm going to have to move 1 billion things. And I'm betting you can guess that your computer's not going to, your computer will do it, but it won't be very happy about it. So this idea, although absolutely 110% correct, is not very efficient. What we're going to do instead is, and we can get away with this because the order of the students in the student class does not matter at all. It doesn't matter if James Hughes comes before Sally Smith. It doesn't matter. So what we'll do is if we have this array, well here, what I'll do, I'll just draw in a new color because I realize we're very, very close to being out of time, is take the student at the last index available, which will always be num students minus 1 because num students always gets us to the index of where the next available spot is because zero-based indexing. So go to num students minus 1, which will always be the last individual here, and put them there. So basically make this pointer point there. Great. Now, this memory address does happen to point to the exact same student object, but that doesn't really matter because we'll subtract. Let me go here and erase all ink. We will say, okay, my class.I is actually going to now be equal to whatever's in the last person. And then we decrease num students. So we can get away, I guess, and then I'm saying return true if we have successfully removed someone, or false if we don't find the person we're trying to remove. Because we decrease the number of students, just because we had that, whoa, that's interesting. Oh, can I make dots if I hold down? Okay, maybe not. Let's not worry about that. Okay. Okay. Just because we have something here and here pointing at the same thing, if we decrease number of students to really be here, we will just immediately overwrite this pointer with the new pointer, so it doesn't matter. We could set this to 0 if we really wanted, but there's no use to it. Okay, we are definitely out of time, but I will go over this again at the beginning of class on Tuesday, just because I know I kind of rushed this at the end, and it's important to understand, so we're just going to, I'll just say it again just to play it safe. Otherwise, have a great weekend, and for those of you in lab this afternoon, I'm sorry, I'll see you later.